Good afternoon. I normally don't read anything, but I wanted to make sure I didn't leave out anything important. So let me begin by saying that I'm going to mention some of the errors that I have encountered in looking at articles, images, videos, and so on in newspapers, magazines, online sites, and also things that I've heard in responses to public presentations I've given. I've given presentations to all age groups, all education levels, urban and rural. And I also, because I travel a lot and because I get around, I have random encounters with people. And if they happen to ask me what I do and I don't lie and they tell them I'm an astronomer, they want to start talking about astronomy. When they hear about the eclipses, they want to start talking about eclipses, and they make a lot of interesting, untrue comments. So when an error can be traced to a misconception, there are well-established ways to work toward countering that misconception. Educators know this, outreach people know this. But what I'm more concerned about is when errors of fact are published in what are reputable sources, or at least purport to be reputable sources, newspapers, magazines, science websites, and so on. So the motivation behind this talk is to help, well, first of all, since you're not all astronomers, to help you recognize some common misconceptions and misinformation, which again, misinformation is not deliberate. It's wrong, however, unintentionally. And I'd like us to not contribute in our own way to the public's growing distrust of experts and the media. So that's my motivation. Okay. I should be able to figure this out. Okay, so I want to start by looking at this map, which you've seen a lot because it's on the cover of all of our stuff. So when Michael Zeiler, who made it, and when I, who use it all the time, and when most of the astronomers and eclipse people look at a map like this, we know exactly what we're looking at, okay? But I want to tell you, none of the things I'm bringing up are made up. I've encountered these things in the media or in public presentations. So which way does the shadow move across the continent? So does it go that way? Does it go that way? Does it go that way or that way? Well, there's the answer. And actually, this question came up during a radio interview the other day. It was a call-in show. David Martin Davies was the host. And the caller said, why does the shadow move the way it does? I don't know if you know this, but it's because it's following the motion of the moon in its orbit. Okay? That's what's making the shadow move the way it does. Why does it go down for one eclipse and up for the next 6 months later? Because the moon's orbit is tilted. And so for one eclipse, the moon's moving down, and for the next one, 6 months later, it's moving up with respect to the plane of the Earth's orbit. So there's a lot of information encoded in there, but I've seen images and I've seen animations showing it going the other way. Okay? So you should know. And if anybody asks you now, you can give the answer. Okay. There's unbelievable confusion among what is the moon, what is the sun, and what is an eclipse, and what are the phases of the moon. And there are countless websites out there. Many of these are new sellers of eclipse glasses who are just looking to make a buck, and they don't know anything about the sky. Can you identify which of these images is the moon, which is the sun, which is both, and which are eclipses versus phases? You probably can. Most people don't seem to be able to. So those are the phases of the moon. How long does it take to go from one, through the whole cycle? A month, right? Takes a month. Okay. Which way does it go? Right to left or left to right? Ooh, a little stumpy. It's from right to the left. In the northern hemisphere. How do you know it's northern hemisphere? Because the orientation of the moon. Okay. Total lunar eclipse. There are lots of solar eclipse websites that show total lunar eclipses. It's sad. I do my best to point it out when I can. And of course, total solar eclipse. Now, some of these things look alike, right? Some of these things look alike. How many pictures of the new moon do you see? How many images of the new moon? 4. 4. You've got the new moon against the sun at the top. You've got the new moon against the sun at the bottom in the middle. Okay. And you got the 2 new moons at the end of the lunar phases. Okay. Yeah. Yeah. Great question. All right. There's a whole article about this on our website, Shapes of the Sun and the Moon. Okay. To try to straighten it out. Okay. We often talk of the 3 different types of solar eclipses, or for the real hardcore people, there's a 4th type, but we're not going to get into it. And we talk about, you're going to have a total eclipse, or you're going to have an annular eclipse, or if you're outside the path, you're going to have a partial eclipse. Okay. We don't mean to be misleading when we say that, but it is misleading because outside the path, everybody's going to have a partial eclipse. But inside the path, everybody's going to have a partial eclipse, followed by a brief annular or total eclipse, depending on the date, and then another partial eclipse. Why does this matter? Well, I'm going to explain that in a minute, but you don't want to say outside the path, you'll have one type, and inside the path, you'll have another. You want to tell them that outside the path, you'll have a partial eclipse, but inside you'll have an annular or a total with partial phases on both sides. Why is this important? It's important for safety reasons, as I'll explain. Here's how an annular eclipse transpires. See the partial phases. If you're outside the path, you don't get the middle image, you don't get the ring. This was brought up yesterday. Please don't say an annual eclipse will occur on October 14th. Now, I know nobody here would do it, but the reason I bring it up is because journalists who are guilty of it are probably just succumbing to the problems with autocorrect. But sometimes they're also succumbing to the problems caused by ignorant editors. So if you're a journalist, you need to watch for this, because when you see the proof of your article, you want to make sure it doesn't call it an annual eclipse. Okay? What you want to say is, all right, come on, is an annular or ring solar eclipse will occur on October 14th, because all people don't know what annular means, right? Okay, so here's how a total solar eclipse transpires. Same thing, partial phases, brief total. And if you're not in the path, you don't get any of that wonderful stuff in the middle. Okay, so why is it important? It's important for safety reasons, actually, because if you tell people, as I often do, that you need to use a filter at all times except during totality, then there's a good chance that they'll follow the instructions correctly. But if you don't, if you just say, oh, during totality, you don't have to look, I mean, you don't have to use protection, they might think that, well, I'm seeing a total eclipse, I don't need to use protection, and that's risky, right? You don't need a filter for totality, but you do need filters on both sides for the partials, and you need it at all times during the annular. And so if you tell somebody they're going to have a total eclipse, you need to be very clear that they're going to have partial phases, and they do need the glasses or some other kind of filter or pinhole projection or whatever it is. I see, even printed on glasses, I see never look directly at the sun without eye protection. And there are still people who say, I don't think I'm allowed to take these glasses off during totality. That's one of the most common misconceptions. And it comes because it's reinforced by this misinformation, which is printed on a lot of eclipse glasses. So when I'm approving eclipse glasses to be listed on our supplier site, I'm telling people, I really wish you hadn't said that. And for people who are sending me designs and saying, is this going to pass muster? I always correct it. I just did it again yesterday. So you tell them, except during totality, don't look directly at the sun without eye protection. You got to give that qualifier. Okay, so after 2017's eclipse, NASA did a survey through the University of Michigan that talked about how many people witnessed the eclipse, and it was huge numbers and everybody loved it. But the interesting thing here is that a lot of people traveled to increase the level of totality, okay? And in fact, only 31% of them traveled into the path, okay? Well, there is only one level of totality, right? Just like there's only one level of pregnancy. Right? I think the confusion came in part because there is a difference in how long totality lasts across the path. not along it too, but for different reasons, but across the path. What we meant to be telling people was they need to get into the path, and if they get closer to the center, totality will last longer. But somehow they just thought that getting close to the path is what mattered. It turns out you can actually get 80% of the duration of totality more than halfway to the edge. So you really don't want to stress this bit. You just want to tell people to get into the path. Don't try to stress that they need to go to the center line, because they really don't. So don't say outside the path, you'll have X% of an annular or total eclipse. Tell them they're going to have X% partial eclipse, okay? All right, I want to show this 2-minute video. It's something I created for our website based on a slide that I've been showing in other presentations. So it explains, it's going to be a graph, and it's going to show you how the ambient light level changes going from the beginning of the eclipse to totality. And the main point is that it doesn't get very dark for anything other than a total eclipse. And when it does get dark, it happens really fast. Okay, so it goes from a brightness of 1, I can't use that, 1 at the top, factor of 10 with each horizontal line, to a factor of 1/100,000th illumination. The horizontal axis shows eclipse magnitude, or the fraction of the sun's diameter covered by the moon. And I'm going to convert it now to just elapsed time, because it's easier to look at it that way. So it takes about 75 minutes to go from uneclipsed to fully eclipsed, totally eclipsed. All right, so let's watch the brightness level change. So now we're almost an hour in, and you'll notice that we're only about 4 or 5% down. And there's a consensus among eclipse chasers that you really don't notice anything until about 3/4 of the sun is covered. And that's because your eyes are adjusting very slowly. Your pupils are dilating ever so slowly, and they can keep up with that change. Okay. But once it gets to about 75%, you're as dilated as you're going to get in daylight. And now you're going to start to notice the change. And even at the annular eclipse, it's only about 10% as bright as a bright sunny day. And it gets darker than that in heavy cloudiness. So it's really nothing special in terms of darkness. But look at that last couple minutes. The bottom falls out. Brightness fades by another factor of 100, even 1,000. And if you are not in the path, you miss that. And you wonder, well, you'll see even at 99 point something, sure, it's going to get dark, but it's not going to get all the way dark. There's still a factor of 100. And you're going to miss all that stuff if you don't get in the path. All right. So you have to get into the path. And again, I don't say you have to get to the center line. You just have to get into the path. Okay. So a few more things not to say. Don't say that an annular eclipse or a total eclipse is a rare event, because it's not. One happens, there's a solar eclipse every 6 months, and there's a total eclipse or an annular eclipse on average once every couple of years. So, do tell them that what's rare about it is that it's coming to you. Okay. It's rare to have it in any particular spot. If you were to park yourself in San Antonio after this eclipse in April and wait for the next one, you're probably going to be waiting several hundred years. Don't say it's a once in a lifetime experience. That discounts the fact that I've seen it 14 times. Okay. Have I lived 14 times? No. Say that you should try to see one at least once in your lifetime. Okay. It's worth it. Now, a total solar eclipse is important scientifically, but nobody except scientists cares about that. What you should say instead is a total solar eclipse is the most beautiful and genuinely awesome celestial spectacle that you will ever experience. Tell them that. That will motivate them more than thinking, ooh, it's really cool scientifically, even if it is. And finally, what are those pink things? What are those pink things on the edge? Most of you know their prominences, but often they're called flares, even by otherwise knowledgeable amateur astronomers. Okay, but a flare is a sudden, very intense brightening of the sun all these phenomena are interlinked, but a flare is a specific release of energy, very powerful, shows up mostly in X-rays, ultraviolet, radio, gamma rays, rarely visible. Prominence is there's energy involved, there's magnetic fields involved, but it's gas that is entrained in magnetic fields above sunspots. Sometimes prominences result in flares, sometimes flares result in prominences, but they're not the same thing. Are those flares? Those are brightenings. Are they Bailey's beads? No, they're Bailey's beads without the E. Almost everybody puts in the E. It's named after some guy named Bailey without an E, all right? Francis Bailey, one of the first astronomers to describe them in print. So there's all kinds of subtleties out there, and language matters. You know, what you say matters, how you say it matters. And so I'm just asking you to be aware of all of these things, because those of us who've been doing this for years, we know how to interpret what we hear and what we see. But for the people, the vast majority of people who are going to be experiencing a solar eclipse, and especially an annular or a total for the first time, they can get confused. And sometimes they'll get wrong ideas about what to do. And the most important thing is that we want them to be safe. So let's make sure we say what we mean. And I think that's it. Yeah, that's it. There's my contact info.